Hello, and welcome again to FlippedHarber for Physics. In this brief video, we're going to talk about position time graphs, a very important topic in physics. Position time graphs are line graphs. Later, as we add acceleration into the mix, those line graphs could turn into curves. We always put position on the y-axis, making it the dependent variable. Time goes on the x-axis, so it's the independent variable. Whenever we're drawing position time graphs, we always make sure that we draw the line or curve in green. The x and y axes can be in regular pencil, but always draw the line in green. That's a standard that we're going to stick with throughout this entire year. Let's take a look at this position time graph from the book. There's actually two objects being represented in this position time graph, and that's very common whenever we want to compare motion of two objects. We graph them together on the same set of axes so that we can see how their motions are similar and how they're different. Now let's talk about some important features of this graph. Let's talk about the starting position first of all. The starting position is over here at time 0. Basically, the y-axis is our starting time. So particle A is starting at the origin, that is, it's starting at 0 meters. I know that the distance is in meters because it's marked right here on the axis. Particle B is starting 50 meters behind. Let's talk about the slope real briefly. We'll learn later that the slope of any position time graph is velocity, but what we need to pay attention to right now is that both of these slopes are positive. Whenever we see a positive slope, we take that to mean that the object is moving forward. If the slope is negative, that simply means that the object is moving backwards. Now, a position time graph really won't tell you which way it's facing, so sometimes driving backwards means that the object is driving in reverse. Sometimes it means that it's turned around. That really doesn't matter for a position time graph. Let's talk about this point up here where these lines cross. At this point, the objects are at the same position at the same time. So that literally means that particle A, whatever this is, has caught up with particle B, whatever it is, has caught up with and is passing particle A. Whenever we see position time graphs cross, that means the two objects are next to each other for an instant. So that's all we really need to talk about position time graphs. You're going to be making them a lot in class. Please remember to always make them in green and always do them as neat as possible. Alright, we're all set, so I'll see you in class and I'll see you online.